Now we are going to start the next topic after projections of solids, and that is section of solids. Now it is somewhat similar to what we were doing in case of projections of solids, because here also it is required to draw different views, that means front view, top view, side view of given solid. But here the difference is that the solid which will draw the projections of, that will have some cut section. That means in the problem statement some condition will be given, like the given solid is being cut by a cutting plane bisecting its axis having inclination with HP or VP. This type of conditions will be given. So what we need to do is we have to first note down the given position of the solid and we need to draw it as we were doing in case of projections of solids. Next, from the problem statement we have to identify the position of the cutting plane. So we will locate it and then we have to take projections from the required points which will give us the cut section. So the thing is, in any one or two views of the solid we will be able to see section also, right? So let's try to understand this by a simple example. So this is the problem statement which we'll try to understand and try to solve. It says a square pyramid is resting on its base on HP in such a way that two base edges remains perpendicular to the VP. So this first statement is defining the position of the solid. Okay, then it says it is cut by a cutting plane passing through the midpoint of its axis. The cutting plane is perpendicular to VP and inclined at 45 degree to HP. This is the problem statement given. So let's first try to understand what is the position of the solid and what is the position of the cutting plane. So if we try to imagine it by this 3D representation, then let's say this is VP. Pyramid is resting on HP in such a way that its two base edges remains perpendicular to VP, right? So we can say this is the position of the pyramid. Okay, and it is a square pyramid. So I am not drawing this hidden line. Okay, let me represent it here. These are the hidden edges. So you can understand that this base is resting on HP. Now let's draw the HP also. So this is the position of the given solid. Now there is a cutting plane which is perpendicular to VP and bisecting the axis of the pyramid. So if this is the axis of the pyramid, the cutting plane is bisecting this axis, passing through the midpoint. Okay, so let's say if this is the midpoint. Now the plane is perpendicular to VP and having inclination with HP. So let me first draw it over here. The plane would be like this. It is perpendicular to VP and having some inclination with HP. So let's say this is 45 degree inclination, right? So this is the plane. Now this plane is cutting this solid. That means it is passing through the midpoint of the axis. So let us now represent it over here. So it will be something like this. It is being cut by this cutting plane. Now let me draw it separately, that after cutting this solid by the given cutting plane, if we remove the top portion of it, how it will look like. So let me represent it over here. It will look something like this. Something like this it will appear, and this is the section. So we have removed the top portion of this pyramid, and after removal it appears like this, and this is the section. Okay, so from the top, if we see, we will be able to see this section. When we look at it from front, we will not be able to see the section. Now we need to draw projections of this, not this. Okay, so now let's try to solve the problem. So we'll go to this page. Now we'll draw the position of the solid. So this is XY line. Now we are drawing, if the pyramid is resting on HP in such a way that its two base edges remain perpendicular to VP, so it will appear like this. This is the base, this is the top view. Now I am drawing this with different color. That means this line should be continuous thin initially, this line should be continuous thick, but now this line should be continuous thin. So I am drawing the slant edges of the pyramid. Initially I am drawing it with continuous thin line, right? Now I will give some notations to this, and then we will project this, this and this, and first we will draw the axis. All these are thin lines, okay, right? Now here in this problem, as I am taking some random example, I have not taken any dimensions, but in the actual problem statement the dimensions will be given, like it will be base edges are equal to some let's say 30 mm, and the height of the pyramid is some like 70 mm. So with those dimensions you will draw this. Basically here you will mark the height of the pyramid, and that will give you the apex. Let's say that is O prime. Okay, and now we will draw the front view of this pyramid which is resting on HP. This is without cut, so that is why I am showing it with continuous thin lines. Next we need to draw the cutting plane. Now as we know that the cutting plane is perpendicular to VP and having some inclination with HP, it will appear as a line in front view, right? If you have some plane which is perpendicular to VP, let's say if this is VP over here, if the plane is perpendicular to VP, then it will appear as a line in front view. Okay, so what we can do is we can draw the cutting plane line in the front view. So where should I draw it? So one condition is it should pass through the midpoint of the axis. So I will first mark the midpoint of the axis. The second condition is it is having inclination of 45 degree with HP. So I will draw the line at 45 degree angle to XY, and that will be cutting plane line. So we will represent the cutting plane line. So that is chain line with thick ends, right? Okay, now understand that the top portion of this solid is removed and the bottom portion is kept. Why we are removing top portion is because if we remove the bottom portion, then from the top we will not be able to see the section, right? Here if we remove the top portion, from the top we will be able to see the section. So that is why we are removing the top portion. That means this is removed now. So what is left? So this portion is left. Alright. Now this cutting plane is cutting this edge and this edge at these points, right? So actually if we now transfer these notations to front view, this is A and D, so here I should write A prime comma D prime. This is B and C, so I should write B prime comma C prime. That means the cutting plane is cutting all the four edges, two edges at this point, two edges at this point. So now we have to give notations to these points also. If we go back to this figure, understand that after cutting we have 1, 2, 3 and 4 new points which are generated. Okay, these points were not there earlier. When the pyramid is complete, we were not having these points. So now we have 4 points generated, 1, 2, 3 and 4. So according to these notations, if we say that this is A, B, then we have at the back C and this is D. Okay, then on the edge A to O, that means A to apex, we have a new point now. On the edge B to O, we have a new point. Okay, so basically now we will give notations to these points. So let's say we are giving this as 1, 2, 3 and 4. Right? So if we show these notations here, that would be like point number 1 would be on A to O. Okay, let me show that this is the apex O. So we have this edge AO and on this edge we will have 1 point. So as per this we have 1, 2, 3 and 4. So I will give this as A prime to O prime, it is 1. So I will say 1 prime. B to O it is 2. So I will say 2 prime. C to O it is 3. So I will say 3 prime because this is O prime C prime also. And D to O has 4. That means this is 4 prime. So I have 4 new points generated now after cutting. Now to complete the top view, I have to transfer these points to the top view, right? So what we need to do is we have to just take projections from these points. So we will take projection from this point and projection from this point, right? Now 1 is located on AO, so I will say this is 1. 4 is located on D to O, so I will say this is 4. 2 is located on BO, so I will say this is 2. 3 is located on CO, so I will say this is 3. And now I need to connect these points. So I will connect them with straight lines. Alright. Also, now as I have kept the bottom portion of the pyramid, so edge 4D will be now visible in top view as a continuous line. 3C will be visible, 2D will be visible, 1A will be visible. And this will remain thin. It is removed, right? Okay. So now to show that this is a section, we have to show section lines inside this. So these are the section lines. Okay, so this was a basic problem just to give an idea about how to locate the cutting plane and how to draw the section in any particular view. So here, as the cutting plane was perpendicular to VP, section is visible in top view. So in some problem, the section may be visible in front view, in some it will be visible in top view, and it will be visible in, it is possible that if all the three views are required to draw, then the section will be visible in two views. Here also, if we draw the side view of this, then the section will be visible in top view and side view both. So let's conclude this session with this basic understanding, and now in the next lecture we will go further in this topic section of solids.